All right, so now we're on the last question of 9.2 mean. How do outliers affect the mean? How do outliers affect the mean? Okay, do you remember outliers? I hope you do. Outliers. Outliers are data values that are significantly different than the rest of your data. I know I hear some of your parents out there are like, actually, the outlier is 1.5 times the IQR. Yeah, I know. There's a formal definition of what an outlier is. That means we can tell whether a data value is or is not an outlier. But for now, just think of an outlier as being one that's way different than the rest of the data. Okay, so let's predict how adding Mr. Plunkett to your group will affect the mean age of the students at your table. Now, I'm of course older than y'all. I'm 100 years old. What? I'm an old man. Okay, so I am 100 years old. If I add 100 to the data set of students' ages that we had earlier, what do you think that's going to do to the mean? Well, the mean, you find the sum of all the data, then you divide by how many there are. Well, the sum is now going to have 100 added to it, but I'm also going to be dividing by a bigger number, right? Because instead of 5 students, now I have 6 students. So what do you think? I predict that adding Mr. Plunkett's age to the data set will make the mean. I hope you all said this. I hope you went, well, that 100 is going to make the balancing point of the data, or it's going to make the kind of expected value of the data. It's going to make it way bigger, right? It's going to make that mean way bigger. Whoops, my pen's not working. Okay. It's going to make it way greater. Let's prove it. So I believe we had a data set something like this. It was like 10, 11, 12, 12, 11, something like that, right? And now we also have 100. And so before, when we added together these 5 numbers, right, it was 5 groups of 10, which is 50, plus 6, that's 56. Now we're going to add 100. So it's 100 plus 56, which is 156 or 156. I don't even know how to say it. And then we're going to divide that by 6. Now I can predict, oh wait, that's just the sum. Whoops, I meant to do that here. The mean is 156, the sum divided by 6. I can predict about what this is going to be, right? It's going to be, I don't know, what, 25-ish. But what we're going to do is use a calculator and just be a little more precise. So 156, this means divided by 6, and I got 26. So I got lucky. I got a round whole number, right? 26. So were we right? Remember the mean before was 11.2, I think, 11 and 2/10. Now it's 26. What did the outlier do to the mean? Well, it changed the mean a lot. It went from 11.2 to 26. I mean, it more than doubled it. Just one data value totally changed what the mean is. So we'll have to think about this. Let's go to the conclusion first. The original mean age of your table group was 11.2. With Mr. Plunkett being added to your group, the new mean is 26. Adding a value greater than the mean to the data set makes the mean greater. So that's the conclusion here. If we add a data value that's greater than the rest of the data, it's going to make this mean greater as well, which makes sense because then that sum gets a lot bigger. Okay, let's move on to part C. Y'all know Mr. Anslow. Mr. Anslow is another math teacher at Travis Ranch School. Okay, Mr. Anslow, he has a kid who is 7. All right. What if I added Mr. Anslow's kid's age, which is 7, to the data set instead of Mr. Plunkett's? That's an important phrase right there. Instead of Mr. Plunkett's. How do you predict the mean would change compared to your original mean? Okay, well, 7 is less than any of the data in our data set, and it's far less than our original mean of 11.2. So what do you predict? I predict that adding Mr. Anslow's kid's age to the data set will make the mean, I hope you know this, lesser. It'll make the mean lesser than. It's going to go down because that 7 is less than the rest of the data. So it's going to make the mean also be less. So over here on the conclusion side, I don't know why I scrolled down so far, but it's okay. We'll remember this. Here it is. Adding a value greater than the mean to the data set makes the mean greater. I thought we already did that. I think I meant to have this be lesser. So I apologize. I'll fix that on your version of the notes. So adding a data value that's lesser than the mean to the data set makes the mean lesser. Outliers affect the whole point of this section is to understand the mean, right? And what are outliers affecting? They affect the mean. In fact, they affect the mean a lot because they can pull the mean up a long ways or bring it down a long ways. All right, everybody, that's it for 9.2 mean. I'll catch you in the 9.3. Make sure you hit subscribe and buy all my stuff on my channel. Bye.